All right, folks, Mr. Buckle back with the definition of sine and cosine. So the sine and cosine ratios, or the sine and cosine functions here, are defined very similarly to the tangent ratio. Just that sine and cosine deal with different lengths of the right triangle from which we're dealing with. So if we're going to let ABC be a right triangle again, because all these ratios pertain to right triangles, with a right angle C, as indicated in the picture here, so we've seen this before. The sine of angle A, written sine A, so you've seen that button on the calculator. Looks like sin, but it's sine. Sine A, or sine, and then you can put A in parentheses. The sine of this value A is equivalent to the length of the leg opposite to angle A divided by the length of the hypotenuse. The tangent function was the opposite and the adjacent sides. The sine function works with the opposite and the hypotenuse. So that would be, if we look at this picture, if I'm looking at angle A, if I want to have the sine of angle A, so whatever the measure of angle A is, that's equal to the opposite side length divided by the hypotenuse. And then the cosine function, looks like cos, C-O-S, the cosine is equal to the length of the adjacent angle, or adjacent side to angle A, divided by the hypotenuse. So if we're looking at it, if we're sitting here at angle A, we know angle A. The adjacent side, which is this side, or the side next to angle A, divided by the hypotenuse. So what does that look like when we're working with some examples here? So here's some examples. We have right triangle, PAL. P-A-L, it's a right triangle. We know that because it has the little right angle there. And we have the side lengths as indicated. 13 is the hypotenuse, and then 5 here is this leg. We want to find each value. We want to find the sine of angle P. Well, here's angle P. And the sine of angle P would be equal to the opposite over the hypotenuse. So the sine of angle P is going to be the opposite side to angle A divided by the hypotenuse. Well, the side opposite of angle P is 5. And the hypotenuse, as we can see, is 13. So the sine of angle P, whatever angle P is, 15, 10, we don't know exactly, but we do know that the sine of angle P is equal to 5 over 13, because the sine of an angle is equal to the opposite side divided by the hypotenuse. So sine of angle P is 5 over 13. That's all we're looking for there. For cosine of P, so if we're looking for the cosine of P, you need the length of PA, because the cosine is the adjacent side over the hypotenuse. So if we're sitting here at angle P, the adjacent side is PA over the hypotenuse. So we need to find PA in order to find whatever the cosine of P is. So we're going to use the Pythagorean theorem to find this missing side length. So here's that work here. A squared plus B squared equals the hypotenuse squared. 5 squared is 25, 13 squared is 169, PA squared is 144, therefore, our PA squared is 144, therefore PA is equal to 12. So this length right here is 12. We found that from the Pythagorean theorem. Therefore, the cosine of angle P is the adjacent side over the hypotenuse. So the cosine of angle P would then be 12 over 13. If we're looking at angle L here, which is what we're going to do next, if we want to find the sine of angle L, we need to have, again, the opposite side divided by the hypotenuse. So the sine of angle L is going to be equal to 12 over 13, because if I'm sitting here at angle L, and I want the sine of angle L, the sine of angle L is the opposite side, 12, over the hypotenuse, 13. So the sine of angle L is 12 over 13. I'm looking for the cosine of angle L, so now I'm sitting here at angle L, but I want the cosine, not the sine. The cosine is the adjacent side, in this case 5, over the hypotenuse, in this case 13. So the cosine of angle L would be 5 over 13.